Sri Gurubhyo Namah children, welcome to online session. Already we are discussing about colloids. So we have talked about, I have told about the classification of colloids, I have told about the missile formation in colloids, and we were discussing about the preparation of colloids, particularly lyophobic colloids. What are lyophobic colloids? They are solvent hating colloids. They won't like the solvent. They are solvent hating colloids. So we have to adopt certain special techniques for the preparation of lyophobic colloids. Already in the previous class I have discussed about the chemical methods of preparing colloids. Already we have seen, we have discussed with the chemical methods of preparing lyophobic colloids. There are 4 methods I told you. I talked about the double displacement, I talked about the hydrolysis, I talked about the oxidation and reduction techniques, where all these techniques are coming under the chemical methods of preparing lyophobic colloids. After that, there are 2 more methods remaining for preparing lyophobic colloids. One is electrical disintegration. What is electrical disintegration? Passing current and preparing the colloids of noble metals like gold, silver, platinum, etc. This is one method. The other method we are going to see is peptization. How colloid is converted into a precipitate, and we are going to see everything in detail now. So up to chemical methods we have completed. Now I am going to start with other 2 methods of preparing colloids. I am going to continue with electrical dispersion of preparing lyophobic colloids. Electrical dispersion. What is electrical dispersion? Passing current, and we are going to prepare colloids of noble metals. What are noble metals? Gold, silver, platinum, etc. We can prepare the colloids of noble metals like gold, silver and platinum by electrical disintegration. Here there is a method under electrical disintegration. We can call it as BREDIG'S arc method. We are going to introduce an arc between the 2 electrodes, where we are going to involve 2 different processes here. One is dispersion, other one is condensation. So this BREDIG'S arc method involves 2 important processes. One is dispersion, another one is condensation. Particularly we are going to employ this method for preparing lyophobic colloids, particularly noble metals, salts of noble metals like it can be gold, silver, platinum, etc. So here this process involves dispersion as well as condensation. So in this technique particularly we are following 2 different processes. One is dispersion, another one is condensation. So there are 2 different techniques employed here. One is dispersion and another one is condensation. So 2 different techniques are involved in the electrical disintegration method. And colloidal solutions of metals like, already told about the noble metals, gold, silver, platinum, etc. they are prepared by this method. So particularly we can prepare the colloidal solutions of noble metals. What are noble metals? Costly metals. What are they? Gold, silver, platinum, etc. We can prepare the colloidal solutions of these noble metals by using this electrical disintegration method. The next one, in this method actually we are going to introduce an electric arc. An electric arc is struck between the 2 metal electrodes. We are going to pass electricity. So we need 2 metal electrodes. An electric arc is stuck between the 2 metal electrodes, which is kept immersed in the dispersion medium. So where are these metal electrodes? An electric arc is stuck between the metal electrodes. These metal electrodes are dispersed. Where they are immersed? They are immersed in the dispersion medium. So what is the dispersion medium here? Solvent. So what is the dispersion medium here? Solvent. So how I have started the experiment? So this is BREDIG'S arc method, and you actually an electric arc is stuck between the 2 metal electrodes, where these metal electrodes are immersed in the dispersion medium, which is nothing but solvent. The intense heat produced vaporizes the metal, which is then condenses to form particles of colloidal size. So here what is happening? I am passing current. current is passed. So what is happening? The intense heat of the arc. So the intense heat which is produced by passing electricity, what is happening? So the metal starts to vaporize. So the intense heat of the arc which is produced, so it will vaporize the metal. So what is happening? The metals are converted into, what is that, a vapor form. So vaporization is taking place, vaporizes the metal which then condenses. So actually what is happening, on passing current, the intense heat of the arc produces the vapors. So the metals will be in the form of vapors. So these vapors, when they are immersed, when they are dispersed in the dispersion medium, what is happening? Condensation is taking place. So these vapors, metal vapors, when they are passed into the dispersion medium, what is happening? Vapors are converted into liquid. So what is condensation? Vapors are converted into liquid. Vapors are converted into liquid. So here in this method actually we are going to get the vapors of different metals. It can be gold, it can be silver, or it can be platinum. So what is that actually? By passing current, the intense heat of the arc vaporizes. As a result, what is happening? These vapors, when they are immersed, when they are dispersed in a dispersion medium, that is in a solvent, what is happening here? Water vapors are condensed, that is vapors, metal vapors are condensed into a liquid. So this method I can prepare colloids of noble metals like gold, silver, platinum, etc. So here there are two processes involved here. One is, what is that? Dispersion, another one is condensation. Actually an electric arc is stuck between the two metal electrodes. These electrodes are immersed in dispersion medium. On passing current, what is happening? The arc starts to vaporize. As a result, these metal vapors, when they are dispersed in the dispersion medium, condensation is taking place. Vapors are converted into liquid. So I can get colloidal salts of gold, silver, platinum. I can prepare the colloidal solution of gold, silver and platinum by this method. So this is electrical disintegration. Now we are going to talk about, so there is a process which has given here. Actually this is dispersion medium. So this is dispersion medium and two electrodes are kept here and a current is passed. So what is happening? The intense, on passing current, the metal started to vaporize. Because of the intense heat of the arc, the metal starts to vaporize. So these vapors are collected, dispersed in the dispersion medium. Thereby condensation is taking place. Vapors are converted into liquid. So colloids of gold, silver and platinum are prepared by this method. So this is actually an electric arc which is kept immersed between the two metal electrodes which are kept in the immersion, what is the dispersion medium. On passing current, the metal starts to vaporize, so which gets condensed. Thereby colloidal solutions of gold, silver and platinum are prepared. The next one we are going to talk about peptization. What is the next method of preparing lyophobic colloids? The other method of preparing lyophobic colloid is, it is nothing but peptization. What is peptization? So peptization is a process where precipitate is converted into a colloid. So converting a precipitate into colloid. So what is peptization? It is a process where the precipitate is converted into a colloid. How can we convert a precipitate into a colloid? By shaking with dispersion medium. So what is happening here? By shaking the dispersion medium in the presence of a small amount of electrolyte. So what is happening here? We are converting a precipitate into a colloid. So precipitate is converted into a colloid. How is it possible? When precipitate, to the precipitate I am adding small amount of electrolytes. When small amount of electrolytes are added to a precipitate, so what will happen? Precipitate can be converted converted into a colloid. So the electrolytes which are added, the electrolytes what we are added for the purpose of peptization is known as peptizing agents. So what are peptizing agents? Actually they are salts. Electrolytes are nothing but salts. The salts that are added to the precipitate, in order to convert a precipitate into a colloid, we can call such electrolytes as, we can call it as peptizing agents. So peptizing agents are nothing but electrolytes which are salts. Electrolytes which are salts. So here actually we are converting the precipitate into a colloid. So what we are doing, in order to convert a precipitate into a colloid, I need some electrolytes, I need some agents. So where these agents, when they are added to a precipitate, it is converted into a colloid. The agents, that is the electrolytes that we are adding to the precipitate to convert into a colloid, we can call it as peptizing agents. What type of substances we are adding as peptizing agents? Electrolytes. What are electrolytes? Electrolytes are nothing but salts. So these electrolytes which are nothing but salts, when added to a precipitate, it is converted into a colloid. So this method is applied generally to convert a freshly prepared precipitate into a colloidal solution. So actually this method completely talks about the conversion of a precipitate into a colloid. So precipitate is converted into a colloid simply by adding the peptizing agents which are nothing but electrolytes. Already we have studied about electrolytes. Electrolytes are nothing but salts, because they are, what is that, they will have ions, is it not? So definitely when we are adding these electrolytes which are otherwise called as peptizing agents to the colloid, so what is that, precipitate? So precipitate is converted into a colloid. So we can call this method as peptization. The next one, so what is happening in the peptization we are going to see. During peptization, what we are going to do? We are going to convert precipitate into a colloid. So during peptization, what is happening? So during peptization, the precipitate adsorbs one of the ions of the electrolyte. So we are adding the electrolyte there to convert the precipitate into a colloid. So when you are going to add the electrolyte to the precipitate, what does the precipitate do? What it does? So the precipitate adsorbs one of the ions of the electrolyte on its surface. So on the surface of the precipitate, so what is this precipitate? What it is going to do? The precipitate adsorbs the one of the ions from the electrolytes which are nothing but peptizing agents. So during peptization, on the surface of the precipitate adsorbs one of the ions from the peptizing agent which are nothing but electrolytes. So this causes the development of positive or negative charge. As a result, what is happening? As the precipitate adsorbs ions from the electrolyte, as a result, what is happening? Development of positive or negative charged particles. So development of positive or negative charge is taking place. Positive or negative charge is taking place on precipitates, and which ultimately break up into smaller particles of the size of a colloid. Actually, during peptization, on the surface of the precipitate, this precipitate adsorbs ions of a electrolyte, and thereby the precipitate is converted into a colloid by the development of positive or negative charge on the precipitate. Thereby precipitate is converted into a colloid. So this method is known as peptization. So they have given here, for example, ferric hydroxide, I am taking a ferric hydroxide colloid. Ferric hydroxide, this is actually, so we are adding ferric chloride here. So what is happening here? Peptization is taking place. We are getting colloidal particles of ferric hydroxide. So ferric hydroxide, actually you will be getting a reddish brown precipitate of ferric hydroxide solution. So actually this picture talks about the peptization reaction where what is that, the precipitate is converted into a colloid by the addition of the electrolyte. Actually on the surface of the precipitate adsorption is taking place. Precipitate adsorbs one of the particles, ions from the electrolytes, thereby converting the precipitate into a colloid. So we can call this as a what is that, a peptization reaction. This is also one of the method for preparing lyophobic colloids. The next one, we have prepared everything, preparation is over. We have completed the preparation of lyophobic colloids. After that what we have to do? We have to purify the colloidal solution. Preparation is over. Once preparation is over, what we have to do? We have to purify the colloidal solutions, because colloidal solutions will have impurities. So, in order to remove the impurities from the colloidal solution, we need purification. What type of impurities are present in colloidal solution? It may be electrolytes. Electrolytes are present as impurities, charged particles. Electrolytes are nothing but they are salts which are charged particles. So actually these electrolytes are acting as impurities in the colloidal solution, so it has to be removed. But already I told you we need impurities only to a small extent. We need electrolytes because everywhere we are talking about the stability. When you talk about the stability of the colloid, how it gets stability? Because of the presence of electrolyte. What is the electrolyte there? There electrolyte acts as an impurity. So the presence of electrolyte should be there in the colloidal solution, but too much of electrolyte, that is larger quantity of electrolyte or a larger amount of electrolyte is present as an impurity, definitely it will destabilize the colloid. The colloids will become unstable because we are very much worried about the stability everywhere. So we are talking about stability. So when you talk about the stability, actually a small proportion of electrolyte should be there in the colloid. Colloid should be associated with the electrolyte for stability. But too much concentration is there. The electrolyte is present in large quantity. In such a case, what will happen? So it will act in a reverse way. So it will cause the, what is that, instability. The colloids will become unstable. So we need to, what is that, control the quantity of precipitate, control the quantity of electrolyte here, so that we can maintain the stability of the colloid. So in order to purify the colloid, what is that? Actually electrolytes are present as impurities. Electrolytes are needed in the colloidal solution only in small proportion. When large proportion of electrolytes are there, so it will deactivate the colloid, or it will make the colloid unstable. That's why what we are going to do, we are going to reduce the concentration of the electrolyte in the colloidal solution to a minimum. So we can call it as purification technique. There are so many methods we are going to follow here for purifying the colloids. That is, we are going to see dialysis, electrodialysis and ultrafiltration. So there are three methods employed here. We are going to employ for the purification of colloids. So colloidal solutions when prepared generally contain excessive amounts of, so when colloidal solutions are generally prepared, they will contain excessive amount of electrolytes. Large quantities of electrolytes will be there in the colloidal solution at the time of preparation, and some other soluble impurities are also there. Apart from electrolytes which are associated with the colloids, we can see some soluble impurities also present in the colloidal solution. So the presence of, as I told you, we need electrolyte only in small proportion. We need electrolyte in the colloidal solution only in traces, only in small amount. Is essential for the stability of the colloid. Already I told you, in order to maintain the stability of the colloidal solution, it needs only small traces of the electrolyte. If the colloidal solution is associated with large amount of electrolyte or large traces of electrolyte, so what will happen? The colloidal solution will become unstable. unstable. The colloid will become unstable. So in order to stop that, what we are going to do? We are going to reduce the concentration of the electrolyte to a requisite minimum so that we can maintain the stability of the colloid. So this is one, that is why we are going to involve the purification technique. Next, it is necessary to reduce the concentration of the soluble impurities to a requisite minimum. So definitely we need to talk about the stability of the colloids only because of the presence of electrolyte, traces of electrolyte along with the colloids are stable. But if the concentration of the electrolyte is too much, if it is greater, definitely it will make the colloid unstable. The colloids will become unstable. So in order to avoid that, what we are going to do? We are going to involve the purification techniques so that we can reduce the quantity of electrolyte to a requisite minimum, to a minimum quantity, so that we can account for the stability of the colloids. Next, so we can work out for the stability of the colloids. The next one, purification. I told you there are so many methods we are going to involve for the purification of colloids. What is the first method? The first method is, I am going to say now, we are going to talk about dialysis. Second one, electrodialysis. The third one, ultrafiltration. So these are the three techniques we are going to employ for the purification of colloids: dialysis, electrodialysis and ultrafiltration. What is dialysis actually? Using a semi-permeable bag. So using semi-permeable bag, we are going to separate remove the ions. Using a semi-permeable bag, we are going to remove the ions which are present as impurities in the colloidal solution, that is dialysis. What is electrodialysis? Passing electricity and removing the ions. Passing electricity and removing the impurities. Passing electricity and removing the impurities, we can call it as electrodialysis. The next one is ultrafiltration. Using a ultrafilter paper, and separating the impurities. Using the ultrafilter paper and separating the impurities. So this is again another method. So there are three methods involved in the purification. One is dialysis, second one is electrodialysis, the third one is ultrafiltration.